All right, boys and girls, I've started the recording. So again, the learning target is I can write prime factorizations of composite numbers. If you were ever to watch a recording, you can always pause it. So if I moved on from a screen quicker than you wanted me to, you could obviously just go back and pause it so that you could write the whole learning target down. So just kind of a reminder to you about how you might do that. Okay, so for today, and again, and when we get to the end of when I stop recording, if you need me to put the learning target or anything else back up, certainly can do that. Just let me know. All right, so we're kind of looking at, I like to call these the factor trees. So if you take 2 times 3, you can get 6. So those are the factors, 2 and 3, and the product or the answer is 6. Notice you can also divide 6 divided by 3 is 2, 6 divided by 2 is 3. So basically, if you have those 3 numbers, you can multiply and divide them in a lot of different directions to get the same answer. The important thing to know for today is what a factor is, okay? 2 numbers that are multiplied together to get an answer or a product are called factors. So today is going to be a lot of practicing our math facts, if you will, our multiplication math facts. So I'm going to be asking you to come up with what I call factor pairs. Okay, and I'm going to show you right here on this page what a factor pair is. Okay, if I start with the number 18, and I would like you all to write the number 18 in your notes, we need to start listing the factor pairs. So the first one to always write is 1. 1 times the number itself, in this case, 18. Another factor pair is 2 times 9. And a third factor pair is 3 times 6. Okay? Yes, you can do 9 times 2 and 6 times 3, but those are the same factor pairs. So if I was going to write it down in order, in numerical order, because you will be doing this on a couple of the problems today, you're going to need to write the answers down in order. You would write 1 and then 2 and then 3 and then 6 and then 9 and then 18. So I kind of would look at all my factor pairs and then I would just put them in order from least to greatest. Okay? All right. Now, we're going to try another one. This number is going to be 75, okay? 75. So look what I did right here. I know that it ends in a 5. We talked about our divisibility rules yesterday, which is why I divided it by 5 here to figure out what the 5 is. So I started with 1, okay? 1 and 75. Those two go together. Notice how I wrote it this way. Now, there's a couple different ways that you can write it in your notes when you're working on the problems today. It's an odd number, so I know 2 doesn't go into it. 3 goes into it 25 times. So 3 times 25. And then I knew 5 went into it because it ended in a 5, but I wasn't sure how many times. So I divided 75 by 5. I got 15, and so I have that right there. If I was going to write it in order, it would be 1, 3, 5, 15, 25, 75. Okay. So today, part of what you're going to need to do is just find factors of some numbers, which is going to feel a lot like review for everybody because you've done that kind of work before. But that's where we're going to do the first few problems on your assignment today will be that. Okay. But the big thing we're going to be working on today is something called prime factorization. So what I would like you to do is I would like you to write down this definition. So it's prime factorization. I'll put a little line right here. Okay, so that you know, here's the definition. There's the vocab word, prime factorization. A number written as the product of its prime factors. Okay, a number written as the product of its prime factors. So yes, you need to write this down. It's a noun. You don't need to write that. You don't even need to write factorize. You just need to write this part right here, okay? This is the definition. Prime factorization, a number written as the product of its prime factors. So factors are a number that you multiply to equal another number. We're going to try to get it down so that the only numbers we have left are prime numbers that you multiply together to get to the answer. I'm going to show you a trick for that. And the trick we're going to use is called what I call the tree method. Okay. I'm going to give you a second here to finish writing down that definition. Prime factorization, a number written as the product of its prime factors. Can I get a yes or a no if we're done writing that?
Yes.
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 Okay.
Yeah.
Some very musical yeses there. Thank you for that. I'm going to move on. Again, if you don't have it written down, I can always put it back up again when we're done recording. All right. So again, here's just an example. You don't need to write this down. So again, you don't need to write this down. Just a quick little example, and I'll show you how we get to this. It's showing the definition again. But if you wanted to find the prime factorization of 12, notice right here that all of these numbers are prime numbers. And if I multiply 3 times 2, that's 6. 6 times 2 is 12. So these other ones, they're not all prime, okay? 1's not a prime number, all right? And actually neither is 12. 2's not a prime number, 6 isn't. 3 is prime, but 4 is not. So it's got to be an answer where all the numbers left are prime numbers, okay? So I'm going to show you this thing called the tree method. All right. And just so you're clear about what I'm talking about a tree. Notice how a tree has lots of roots underneath. Just how it got, this is how this method got its name, because you're going to end up making lots of like, I'll call them branches. So you'll start with a number and then there'll be a lot of branches, kind of like the roots of a tree, okay? It looks like this. So let me show you how I did that. And I actually want you to write the number 36 in your notes, okay? And you're going to do this. This is exactly how it works. Is you're going to write 36 and you're going to draw 2 lines, okay? And it's always going to be 2 lines like this, sort of like what I would call a caret or an upside down caret, because it's going to be the 2 factors, right? 6 times 6 are 36. Then what I need to do is I need to go and think of numbers that you can multiply that go into 6. 2 times 3 is 6. The reason I circled the 2 and the 3 is because they're prime numbers. I can't go any lower than them, if you will, because no number except 1 and itself goes into it. And in this case, both were 6s. They got down to a 2 and to a 3. So look, I have 2 2s left and 2 3s left. I circle them for a reason. Any number that's circled is going to end up in my answer. So my answer would be 2 times 2 times 3 times 3. If I ever have 2 of the same number, I can write it as, in this case, 2 squared times 3 squared. Both of these would be considered correct answers. Now, I want you to notice how I can get the same answer even if I choose different numbers, because 36 has a lot of factors. So I could also start with 4 and 9. And then from 4, I would go and get 2 times 2. And from 9, I would get 3 times 3. I would have circled all those because they're prime numbers. Remember, I'm only circling a prime number. And I have 2 times 2 times 3 times 3. Now, when you write the final answer, you need to start with the lowest numbers and kind of go from lowest to greatest when you write it. So left to right is lowest to greatest. Okay? All right. So that was one that was already kind of done for you that I showed you. Let's do one together completely on our own, okay? So what I need to do here is, you just bear with me for a second. I need to make a blank page. All right, and I'm going to put the number 54 in here. Can anybody tell me, you can just unmute yourself, two factors of 54. Any two numbers that go into 54.
9 and 6.
9 and 6.
Hold on 1 second. I need to make sure I get somebody got knocked out, so I'm letting them back in, okay? All right, I heard 9 and 6. Patrick, are you back there? Are you back with us?
Yeah, okay.
Okay. 9 and 6. Now, there are other numbers. Actually, 18 times 3 is 54. Maybe you knew that. Maybe you didn't. 54 is an even number. You could do 26 times 2. I'm sorry, 27 times 2. You could start with anything. And you would still get to the same answer. So now, are 9 or 6 prime numbers?
No.
No. They have more than just 1 or 9. So what are some other factors of 9?
3 times 3.
3 times 3. Is 3 a prime number?
Yes.
So I'm going to circle both of them because they're prime. That means I'm done there. I can't go any further. I can't make any more branches once I get to a prime number. And 6 is 2 times 3, okay? And both of those are prime. Now, I've got 4 numbers, which means they're going to get multiplied together, but I have to start with the smallest one first. So it's 2 times 3 times 3 times 3. You could also write it as 2 times 3 to the third power, okay? Either one of those would be considered correct. All right? All right, we're going to go do a few more together, and then I'm going to let us get started on our own, okay? So I'm going to do one more, and then I'm going to stop the recording, then we'll do a few more together, okay? So let's start with the number 48. Any ideas of some numbers that go into 48?
6 times 8.
6 and 8.
Okay, so I heard 6 and 8. What goes into 6?
2 times 3.
Okay, we know both of those are prime, so we're going to circle those. For 8, we have 2 and 4, right? 2 times 4. 2 is prime. 4 is not, though, so I need to keep going. So anytime there's a number that's not prime, I just keep going. In this case, I get 2 and 2, and I circle those. This is why we circle them, so that no matter how far down the branch it is, if it's circled, it's in your answer. So there's 1, 2, 3, 4 2s and 1 3. So it would be 2 times 2 times 2 times 2 times 3. There's your answer. Again, this is called prime factorization. Okay, I call it making a factor tree. If I ever say factor tree, I'm talking about prime factorization. Okay, I'm going to stop the recording right now, and we're going to do a few more problems together. Okay.